All right, we're going to go ahead and get started. So before we jump into this, I just want to get a feel for the room and understand where you're at. How many of you are using Kubernetes today? A good portion. Do you feel really comfortable? Like, I'm super comfortable with Kubernetes. I don't really need any more information about Kubernetes. Or are some people feel like, yeah, if you could get a little bit more into the Kubernetes part of this equation, I just want to get a feel for where people are at. OK, so that gives me kind of an idea of where you might be at. Now, feel free to, as you have questions, raise your hand. And if it's an opportune moment, I'll just jump over and say, hey, let's talk about that, or let's answer a question. And it's not like we're in a giant auditorium with 2,000 people, so we can afford to have a little bit of conversation as we go along. So today's talk is your first microservice with Kubernetes, Helm Charts, and Redis. So of the room, there were some people that were working with Kubernetes. How many people are familiar with Helm? Fewer. OK, so I'll kind of introduce that concept. So our goal is basically to deploy your first microservice, right? And we're going to use Helm Charts and Kubernetes and Redis to do it. So let's get that over with, and then we can get to the meat of it. I've got here a dashboard where I have a number of different Helm packages. And one of them is a Redis package. I also have the option of using the high availability version. And I can click Install and select a cluster that I want this to go to and a namespace, and I can click Install. OK, so that's it. We're done. Any questions? So this is the promise. Now, obviously, in the back end, a whole bunch of complex stuff just happened. And you're probably wondering, what goes into this? How do you even make it work? How do I make it work in my own environments? Because a parlor trick like hitting install on a button, that's, I don't care about that. Fair enough. OK, so we're going to dig into it, and we're going to come back to this. And we're going to talk about exactly what it means to deploy a microservice on Kubernetes and how we deal with state and how we think about state on Kubernetes. So just to introduce myself, my name is Dan Garfield. I'm the chief evangelist for a company called Codefresh, which is located down in Mountain View. And I work with, from a partnership standpoint, we do a lot of work with the Google Cloud team, with the Azure Cloud team, with AWS, with IBM even. And then we have a lot of partners, technology partners that we work with. And so the teams that I interact with predominantly are like Kubernetes native, Kubernetes focused teams. And so I come from a background of kind of Kubernetes and less background on the stateful aspect of things. I'm not a Redis expert. So I feel a little bit afraid that somebody's going to ask me how to do something with like a key value store, and I'm going to be like, I don't know about that. So please don't give me any of those questions. But in terms of how do you bring this stuff together and how does it work on top of Kubernetes, I'm happy to tell you about that. So hopefully you'll find it valuable. Now what we'll cover, we'll do an intro to stateful apps on Kubernetes, like Redis. And we will talk about some best practices. And then we'll talk about how we can use data to do functional testing before we deploy changes. And then we'll do some continuous delivery with that data intact. And then we'll kind of do the demo, and we'll take some Q&A. Sound good? Everybody's enthusiastic? Excellent. So every single application out there requires stateful containers. It's always the case. You might have some stateless stuff like Nginx and Node, but even those things have some state. I mean, you have a session, right? You have a pod status, but we don't think of them as stateful in the sense that they like a database, like that they're going to restore with anything. And then you have your stateful applications, like Cassandra and MySQL and Spark and Kafka and all these things, where they need a volume that's going to be persistent. And we have two different kinds of state. We have the state of the data and the state of the application state. And we're actually going to, for the purpose of this talk, we're not really going to delve into application state. We're going to be talking more about data state, just for simplicity's sake. There are some things you can do on application state. And to give you a sense of the world of containers and how you deal with state, I want to give you an example of something that I see a lot of people do who are using Java. Any people using Java? That's OK. I won't hold it against you. So one of the classic problems with Java that you have to do is garbage collection, right? Now, if you're Kubernetes native, means you've deployed your application in a way where you can have multiple copies, multiple instances, and it should take less than a second or two for a new version of your application to come up, for a pod to recover. So what I've found is that there are actually a lot of teams who turn off garbage collection on Java, because what they do is they just let the pod kill itself, and it just runs out of memory and dies, and Kubernetes like sprouts up a new one before you notice any difference. So this is like an example of kind of the container-aware, kind of Kubernetes-first way of thinking about your application. Now, when it comes to stateful applications, obviously you're going to want to make sure that there's a graceful right, to finish out its state if you were going to do something like that. Wouldn't necessarily recommend that strategy with something like Redis, but it gives you an idea. Now, before containers, single applications per server, we had these kind of manual CI/CD processes, and these were very common. And I was working today with a guy named Eric Hahn. He was the original Kubernetes product manager. And he used to work at Microsoft, and he worked on the Zune. And when I found this out, I was just like geeking out, because I had a Zune. I had like the cloudy, the semi-transparent. Nobody remembers that? One of you? Thank you. Zune buddy over here. iPod crowd, everyone else. He was telling me this story about how kind of before containers and before this whole thing, he planned on doing this release where it was going to take a few hours, and he had a newborn. He had like a 5-day-old, and he told his wife, listen, I need to go into the office. We're going to do this deployment. I'll be back in a couple of hours. And then the deployment took 5 days. Nightmare. And it's really endemic of how things used to be. They were really rigid. They didn't scale very well, and it was high cost associated with it. And a lot of that's because the declarative element that Kubernetes gives you was missing. So now with stateful containers, we have this kind of dynamic app mix where it's dense. We have lots of applications, and we can have tons of instances of Kafka that are all dealing with things, and they're connected to this sort of state. And this should be a low cost to run that application. The management should be very automated because you're using a declarative standard. Okay, all of these things are declarative standard. Docker files are declarative. Kubernetes configurations are declarative. Helm charts are declarative. So that means that you can say, this is the state that I want it to be, and now it's repeatable, right? You've created a repeatable process where you now have a ton of flexibility in how you deploy and how quickly you do it. And you can see this. If you look, if you just Google like time to deploy graph, and you'll find that over the last 10 years, especially as people adopt containers, the mean time to deploy changes, and the frequency has gone down dramatically. And so if you're in an organization and you look like a pretty savvy crowd, most people are in a state where they're deploying several times a day with no hiccups and no problems. But that's the state you want to be in, right? You don't want to have these giant quarterly omnibus deployments with millions of changes, and then something's broken, and you're like, do I roll back? I mean, it's a nightmare. But if you do micro changes to your application, you're committing, all the time. It's like little earthquakes, right? They're no big deal. It's the giant earthquakes that become a big deal, right? And that's because the tension is built up, and there's so much movement that has to happen at once. So the way that Kubernetes handles this, and I'm sorry, this pod that says Mongo, it should say Postgres. But basically on Kubernetes, I have my pod. And my pod contains my container. My container is an image, right? It could be Postgres, it could be Node, it could be a Redis. Actually, it should say Redis. The application example I'm showing has a Postgres and a Redis component in it. So I'm sorry, assume it says Redis. So that pod basically declares a persistent volume claim. It says, I want a persistent volume, please provide it to me. And then Kubernetes, and all this stuff in kind of this box is vendor agnostic. It doesn't matter if you're running your cluster on kops or OpenShift or GKE or whatever, that stuff is vendor neutral. Now underneath that in Kubernetes, you're gonna have a storage class, which is going to be providing a persistent volume. And those are the things that can be vendor specific, or the things that can be sort of cluster specific. But at the end of the day, your Kubernetes application shouldn't necessarily care because it's getting a persistent volume. It doesn't need to know where it's coming from because that's abstracted away. So what it looks like, and this is an example of a Kubernetes configuration file. We have here the pod configuration. You can see there's this volume claim where we say, I want to have a persistent volume, and this is the name of the claim. It's seeking volume, okay? Then over here I have my persistent volume claim. It's named seeking volume, and it says resources. It says, look, I just need 8 gigs, and I want it to come from this specific storage class. And I'm going to talk about the storage class in a second. Now this storage class, in this case, I'm going to use actually a proprietary one. Now, if you're using GK, you're going to get one out of the box. There's a special reason why for this demo I'm actually using this specific vendor, Portworks, to do it, that you'll see in a second. But basically what it's going to do is serve up a ext4 file system for my volume claim to use. And this is going to give back to Kubernetes a persistent volume. That's 8 gigs. It's going to give back the specification of what was asked for. You'll notice that 3 is missing. Did anybody notice that 3 was missing? You didn't notice that 3 was missing. Don't front. 3 is missing because there's a little extra stuff that Kubernetes is going to kind of do behind the scenes that we're not going to cover today. Okay, so the top problems with stateful containers in production, one is it can be easy to get stuck without high availability because the app wants to fail over to a new server, but the data is maybe stuck and mounted to an EBS volume on an old server. So you can't have it in both places at once, and this becomes a problem for a stateful application where you want that high availability. You also have some challenges with data protection because generally those data layer things, and I'm not a huge infrastructure guy, and so this is like getting into beneath the Kubernetes grounding that I want to stand on. So this is more to kind of tell you how the sausage is made, because in a second you saw in the beginning I said hit install and it was like magic, right? So we don't necessarily have to know all these components, but I want you to understand that there's some complexity here that's happening and there are some things that we can solve with it. So one of the challenges with when you first move to stateful containers in production is lots of times your backups are VM level. They're not application level. And the VM is unrelated to our pod, right? Because each pod is going to have a volume, right? They're all connected with their own volumes, and so I don't need a snapshot of a VM. That's not useful to me. I need basically a software layer that I can pull the snapshots from. And then, of course, there's an issue with running multiple containers per server where you can get some poor performance because maybe the storage isn't being allocated in a kind of an efficient way, and maybe it's moving like cross-network in a bizarre way. Those things can become challenges, and they'll introduce latency where you shouldn't have any because you should be able to just declare what you want to have happen, and it should happen, right? So all this stuff isn't to introduce a bunch of complexity. It's not to confuse you. It's not to say, look, you can't do any of this stuff. This is confusing. I know there's a lot of stuff here. It's okay because a lot of this, again, is basically going to be abstracted away from us by our storage class and by Kubernetes. So the service that I'm going to be using is called Portworks. And they have a really great integration with Codefresh. And basically what they do is they provide a software-defined storage layer. And this becomes really important when you are using Kubernetes. So if you've got your Redis instances, you want to be able to attach the storage to them that's sort of highly available and can swap and can come back up. And so you have high availability. And we can basically provide that at a software layer to the application so that each pod can consume what it needs. The other let's see, is there anything else on this I need to cover? Yeah, I mean, it basically unifies and pulls together lots of different storage control into a single interface. And it also orchestrates the scheduling with the storage so that you have sort of optimal placement so that you don't have kind of traversals happening for no reason. and it integrates directly with the scheduler. So the way that we actually work with this, because it is a storage class, is basically through the Kubernetes API. So I don't need any special tooling to work with it. It's sort of a native experience. And the other value here is of using the Portworks in this instance is that it's basically lining up again with that Kubernetes cluster, and I can encrypt keys. I can encrypt these volumes, and you can bring your own keys, and so you can handle kind of the PCI compliance elements of this. And then of course we can also do a lot of interesting stuff with backup and restore that happens very quickly because it's sort of happening in a software layer, so it's much faster. So what I'm going to show today is an example where we deploy a microservice application that has a Redis instance that needs a persistent volume, and we need to be able to snapshot it and push it into staging. And one of the cool things about this is that it means that when I run tests, I can have real live data on my test instance. And so I get much more valid tests. I have much more, a much higher degree of confidence that changes that I make to my application are going to work. And you'll see a little bit of how this Helm chart comes together. So the example application I'm going to use today is something called the voting app. Those that are in the container space will kind of be chortling to themselves because this is a very common application that's used for examples. It's made up of 5 services. You have the voting app, the result app, and the worker are all in one repo. That's my code base. And so I've got a mono repo set up with these 3 different microservices. They need to build on their own. And then I have this Redis and this Postgres instance. And Redis is basically acting as a messaging queue, fairly popular use case for Redis. And those 2 elements need to be stateful. So I need to give them persistent volumes. Now, earlier when I deployed a Redis chart onto Kubernetes, I can pass in a value that just says be persistent, and it will do it because the chart defines it. So you might be wondering, well, what the heck is the Helm chart? What does this Helm thing have to do with anything? Fair enough. So we have to remember, our application, each of these things, they're basically their own container. Now, I could have multiples of them, right? I could have 50 containers for that voting app, and it's fine, right? Because it's scalable. And how these containers all work together, this is something that you can define with Helm. So Helm is a package manager for Kubernetes. So those that have worked with Kubernetes before will be familiar with the idea of creating a deployment YAML and a services YAML and maybe a service class YAML to declare those elements. But when you start having this complex mesh of applications, you want a package manager to basically say, well, this is, when I stand up my application, these are all the components that I need, and this is how they talk to each other. And I can template it, and I can use values to basically change the configuration of how this thing runs for testing purposes or for deployment purposes. It gives you a lot of flexibility. So do people, just give me like a nod if you feel like you get what Helm does, you feel more or less comfortable with it. There's 3 of you. Question, yeah.
Like OpenShift in your stack as well, would Helm feed in or be able to use Helm as part of that?
Yeah, your question is, if you have OpenStack in your stack, can Helm feed, OpenShift. Okay, yeah, from Red Hat, yes. Can you feed Helm into it? Yeah, Helm is a Kubernetes native, not native, but Kubernetes is, Helm is a Kubernetes entity. So as long as you have a cluster, yes, because Helm is basically going to take your, it's basically going to render Kubernetes configuration files, is its job, and then to apply them and keep track of the versioning between them. So basically also brings versioning to your application, in a sense. Yeah, question before I go forward. You'll have to speak up. There's a fan right behind me.
The OpenShift management console, doesn't it include the same thing as Helm?
Does OpenShift management console include the same thing as Helm? I'm not super familiar with Open Management Console and how it deals with templating and like if you have packages that reference packages that reference packages and how it kind of grandfathers things. So I can't speak with even a moderate degree of certainty. So I'm sorry I can't answer the question. But just to repeat, in case everybody didn't hear, the question was, does OpenShift Management Console cover the use case of Helm? My sentiment is that it doesn't, but I'm not entirely sure because I don't have experience with it. Yeah, good question. Any other questions before I move forward with the Helm stuff? Okay, we're comfortable. Okay, so here's the continuous delivery pipeline that I've set up here and that we'll demonstrate. And we'll dig a little bit. We'll come back to kind of how we got this thing up and running in the first place. We'll describe the packaging of it. But basically, I'm going to make a commit from Git. It could be GitHub or Bitbucket. We don't really care. The important thing is that the code is somewhere, it's changed, and it fired off a webhook. Because now I can build my images and my chart. What are the images that I'm going to build? Voting app, result app, and worker. Right? Those are the 3 images that I need to build. And then I need to pull in the Redis and the database and the Postgres in order to package them together for deployment. So that's what I'm building. Then I'm going to clone live data. And clone here is a bit of a misnomer. I should say maybe snapshot live data. Because what I'm actually doing is not creating a copy of the data. I'm doing a copy on write. So basically what it does is it creates like, you could think of it like a virtual volume. And that volume is essentially empty. It just points to the original volume. And as they diverge, you basically get a diff in this virtual volume that records what has changed. And so I'm not wasting any bits to store data that's stored somewhere else. And I'm only making copying changes as they diverge. And that means that I can make a snapshot in like 4 seconds. I mean, it's super fast. It hardly takes any time. It actually takes more time to start the step to clone the data than the actual clone snapshot takes in and of itself. Okay, and then that clone, as I'm calling it, the snapshot, will set up a new PVC, a new provisioned volume. A new persistent volume claim that will be ready so that when I deploy my application to a one-off environment, it'll be waiting. And so my live data will now be in a fresh, ephemeral, one-off instance where I can test my data. Now, traditionally, a lot of people will say, well, you could just use a staging server for this, right? True, you could use a staging server. What if you have 1,000 people working at the same time? Maybe not, right? Because now they're all kind of queuing in, and you'll say, well, I'll just have 1,000 servers. And then you're thinking, well, now I'm paying for a bunch of compute time in the middle of the night, so I'll schedule it. You've just bought yourself a really hard problem to try to scale that way. So what we can do with Kubernetes doesn't care. Just tell it, I want a new version of my application. Boom, you've got it. It takes a few seconds. It's not a big deal. So you don't need to have sort of allocated server for it. We're going to run functional tests. In this case, I'm just going to use Selenium. But examples of functional tests would be UI, integration tests, running performance tests. There's actually a great case to be made for running security tests at this point, and because if you think about a blue-green deployment, you bring up your application, you have your application running, you bring up a new version of it, and then you switch the networking over, right? Because this application's up to date. We're essentially doing a blue-green deployment, except we're not going to switch the networking over. But we're going to treat it as if it's totally live. It's actually going to even be in our production cluster in this instance. And then it will remove the one-off environment, and I'm probably going to disable that step so that we can go and look at how the data sort of diverges as we go. Clear enough? Clear as mud? Those that are standing in the back, feel free to come in and sit down. You won't bother me if you come in and sit down. There's lots of room up here. You don't have to stand the whole time. So let me introduce you to the application really quick. And I'm going to go over, and I'm inside of Codefresh here. I basically have a platform here for managing these pipelines that I'm talking about. And you can see I've got a cluster here called demo with a couple of different namespaces, and here are my different services. These are what I described earlier. There's the Postgres, there's the Redis, There's the app result and the vote. And then the worker isn't exposing a service, so it doesn't show up here. It's actually just a deployment because because of how it's functioning. It doesn't need to be able for somebody to call it. Basically, it's only calling other stuff. So let me show you this application and what it does. It is a voting application where we can decide on cats versus dogs. Fairly straightforward. Anyone that's enterprising and wants to type in this IP address, and you really want to zoom in, you can go and vote on this application, and it will change the state of the app. I'll read it out, because I see a lot of people want to do it, and usually people don't want to. 35.192.218.160. So go ahead and vote. Get your votes in right now. I'm a dog person, and if you're a cat person, you're wrong. So just deal with it. And if you decide not to vote and you're a cat person, then you're going to pay for your ambivalence with a poor record here. And we can look at the result, and we can see the votes are coming in real time. It looks like dogs are still winning, though I did as much as I could to antagonize the cat people, maybe spur them onto action. All right, so we're at 35 votes. So in a sec, I'll give you an extra 2 seconds here, and then I'll maybe ask that you stop so that we can see how the persistence is going to work. Okay, everybody done voting? All right, phones out. Please don't vote anymore, and that way we'll be able to check the state later. And maybe in a minute, I'm going to ask you to pull them out and make changes, and we'll be able to see how our data has started to diverge in our staging instance. So now you know what this application is. So we're stopping now, and let me just refresh and make sure that everything came through. We're at 38 votes. Dogs are winning 53 to 47. Okay, so we'll leave that running. Now I'm gonna fire off a change, and let me grab. Oh, let me familiarize you with one more thing before I make that change, and I'll make this a little bit larger. A lot of people will recognize this. This is basically what Kubernetes has running right now. You can see the worker, the vote, and I'm going to show it this way because it's going to happen. It can happen fast enough that it gets confusing. So it's nice to be able to see it here. When we kick off the pipeline, it's basically going to create all those services from scratch, but they're going to be called staging instead of prod in the beginning. So we'll look at that. We'll come back to it. So let me make a change. Let's make a change to the result, and I actually haven't made a change to the result before, so doing it for the first time in front of you seems like a great idea. All right, and we've got our, zoom in on this. Can everybody see this okay? It's not critical, I guess. You've all seen people edit code before. So I'm going to go in and look and see where maybe a good spot is to, I'm going to change it so that it says label cats, and I'm just going to put in lame. Sorry, cat people. I think that'll work. I can't remember how this application actually, how it actually works, but I think it'll work. All right, so I've got my commit. And I'm going to name it antagonize cat people as much as possible. My last name is Garfield, but I don't like cats. Conversely, my favorite food is lasagna, so, you know. All right, I'm going to commit that. And push it. Before I hit push, I'm going to change screens so that we're looking at the pipeline. Now, I didn't give you really a tour of Codefresh. Basically, you have up here, you have a place for connecting your repositories, a place for seeing and running builds and seeing their logs and those things, a place for images, which is, we have a built-in Docker registry that we're using to handle a lot of caching and image annotation information. We have a Docker Swarm section, which we'll skip, and then we have a Kubernetes along with Helm releases and Helm charts, where we can see what's currently running. And if I look at this Helm release section, we'll see this prod voting app is currently deployed. It has 31 revisions, and I last modified it 3 hours ago. And I could dig into that and see the history, and I could issue a rollback if something was broken, that kind of thing. Fairly straightforward. All right, so if I go to repositories, I'm going to open up my pipeline here. And what I've done is I have these 3 extra pipelines. And the reason I did that is because I have a pipeline to build each image. So remember, there were 3 images that I need to build. So what I'm going to do to be efficient is when I kick off this build, it will actually kick off 3 extra pipelines to build all those images. And then it will pull back to my original pipeline, package them into a Helm chart, and deploy it. Is that clear? Nods? Nods? Thank you. Great audience feedback. Thank you. OK. So let's go to the builds, and we'll kick this off. And within a few seconds, it's going to fire off the webhook. Let me zoom in just a tad, just a titch. And we'll see that it's going to fire off. Now, what it will do first is it'll clone all the code from my repository where I made those changes. And then it will check to make sure that it's not building images for no reason, that the code has actually changed. And then it will kick off those 3 images to build. When those are complete, I'm actually going to build a test image, which is going to basically do my Selenium work to go and talk to Sauce Labs. They've got a whole grid that they'll spin up for me to run all my tests for me. So there go the 3 builds. They're pending now. And they should take only a few seconds. Now, the way that we've engineered this, the images are super, the builds are super optimized for speed. And so it will basically take all of the layers that didn't change, and it won't rebuild them. We will attach a volume to pipelines as we run them again. There's a lot of secret sauce into kind of how we optimize this. So those builds will probably take about 30, 40 seconds to build the entire Docker images for those 3 different services that we talked about. And then again, the Redis part, it's going to pull in from the official Redis Helm chart that's available out there because it's listed as a dependency. And we can look at the anatomy of this in a second. OK, so that finished. It built those 3 images. We can see those are here. Now it's going to create the snapshots. And as I mentioned, the snapshots took 5 seconds to run. I'll show you those. They're basically just Kubernetes configuration files in order to create those snapshots. And now it's deployed to staging, and it's creating those environments. And if we go back and look at here, you can see that this one's not ready yet. And usually, yeah, there goes Redis. And now the entire staging application is up and running. We are going to wait for an endpoint. So we're waiting for those IP addresses to become available. Now, I could speed this up by providing a static ingress with basically I can dynamically create routes off of an ingress. So I wouldn't have to wait for an IP address. I could just use like a node port, for example. But I didn't do that for this example because I needed a little bit more time to talk. And also, it would have taken longer. So I apologize for my laziness. So while this is running, oh, I forgot I was going to cancel the teardown. So maybe I'll interrupt the pipeline so that we can see that in action. I'll have to be quick, though. So let me minimize these. I am using GKE here, and so it's usually pretty good about provisioning IP addresses. Their networking is very fast. I always joke with my mom, because I host my mom's blog on GKE. I always joke with her that she has the same load balancer as YouTube, which fails to impress her every time I mention it. OK, we got that IP address. It's going to build the test Docker image. And we can actually pull this up and look at it right now. Please don't vote on this one yet. But we can do that later in a second. Still coming up. It's going to run those functional tests now. This whole process is pretty remarkably fast. I mean, at this point, we spent a minute waiting for an IP address. So that's not too bad. And then the anatomy of this, of course, there's a lot of Kubernetes configuration files, but they're mostly being generated by Helm, right? So I basically pass in values to handle those elements. And as these functional tests complete, which right now they're running against live data, we'll have our application fully kind of up and running. So yeah, it has come up. There it is. It's now available. Those will complete in a few seconds. Just take a break, get a drink. All right, it's deploying to production because everything passed. And once that's complete, I'm going to cancel it. Let's stop it because I want it to not remove the staging environment. So we just completed the whole pipeline. Let's see if it worked. I made a change to the result, I believe. Lame. There you go. And this is the part when you clap. You clap now. Thank you. All right, so the whole thing worked, right? Now, we've got 38 votes on this is the production instance, right? But what about on our staging instance? What's going on over there? And let's take a look by pulling up the endpoint. So now we'll see. Where did they go? Oh, did I already remove it? Was I not? Shoot, I wasn't fast enough. I didn't cancel it fast enough. It already destroyed the staging environment. So now I can't show the, sorry, got to work on that timing. I meant to comment it out beforehand. But the key element here, and we'll go into the anatomy here for a second, is that because I'm using Helm with Kubernetes to bring in my packages such as Redis, I can instantly bring up my entire full stack. Now this is a five microservice application, but what if you have 150? Does it scale for that? Yes, it does. It does scale for like 150. So if you have even a very complex environment, this can basically give you kind of almost instant failover in a sense, but it gives you that power to do better testing, better application, sort of reliability. So when we look at, and I'll share this repository one more time with you. This is the URL if you'd like to see all the, if you want to see all of the configuration that I did. This is github.com/todaywasawesome, which is me, /example voting app. Okay, and in there you'll find that there is a. Let me just open this. Let's just look at the anatomy here for a second. There's basically a Helm package, and the Helm package, these directories don't need to be here, has a number of charts that have been defined, okay, that have been packaged, and it's going to use this Redis and this Postgres by default, and then I'm actually building the packages for the other ones. And so on the local charts, you'll see the packages for the result, which has the chart YAML, the values YAML, and then each one has sort of their deployment, and SVC and those components. So if you're getting ready to run microservices in your organization and you want to package into a Helm chart, this is a really great demo application to get started with because you can see the whole anatomy, you can see how everything interacts, and there's also all of the code for the pipeline that I just ran is sitting in there as a, it's a file called Codefresh demo pipeline.yaml. So you'll be able to read exactly what happened. And I'll show you one more thing on the stateful side. This Portworks script is really slick. So to create the snapshot for Redis here, this is the YAML that's being applied to Kubernetes. And basically it just says, please kind volume snapshot. Name is what I want to name that snapshot, and then the persistent volume that I want to pull from, which is the prod voting app Redis. Okay? And now when I restore it, it's going to do this restore Redis YAML, which basically says, I want a new persistent volume claim. I'm going to name it staging, same thing but staging, and I'm going to pull in this snapshot that's been created, and this is going to be a read write. This is and the rest of the the size of it, etc. So this gives me this is what's going to create that persistent volume, so that I can connect to it with my instance. Does that make sense? So solid, great. All right. So let's jump forward. Demo. Oh, I always forget to show this demo time slide. It's supposed to break the ice before I do the demo. It'll break the ice after. Thank you. I'm glad it worked. To help you get started, if you do want to try this example, we do have a $500 GCP credit, Google Cloud credit that we offer to people who sign up for Codefresh and connected Google Cloud Google Cloud Cluster, GKE cluster. There are some caveats to that. It's up to $500, depends on your situation. Google has to approve all the credits, and so I suggest using like a work email address when you complete the application part. But basically, create the Codefresh account, create a Google Cloud account, create a GKE cluster, go to Codefresh and connect cluster, and once you've done that, you'll get an email with how to do the rest of the process. So with that being said, now is a great time for questions. Questions? Yes?
Is it a custom pipeline or that's by default?
Yeah, the question was the pipeline that I showed a default pipeline or is it custom? And is it sort of a default to Codefresh? It's not default to Codefresh, but Codefresh has Codefresh is basically a couple of components. There's the pipeline, there's the image management, there's the chart management, and there's the Kubernetes dashboard. When it comes to the pipeline, we have a Codefresh YAML, which is a DSL we developed, but it's very straightforward to write. It's very easy to work with. And I'll show you one little tidbit on this. When I go and I actually look at the configuration here, you can look at the pipeline. I've passed in a bunch of environmental variables. I've got stuff encrypted in there. It's fine. But each of these steps that executes, so here's the step to build all my services. These each execute in their own container by default. Now they're connected by a persistent volume across all of the pipeline steps so that I can pass variables between, and it also makes it so I can restore a cache if I need to build stuff later. So this is actually fairly straightforward to write. You can basically define a Docker image you want to pull in, and then execute commands or pass environmental variables to it, do cleanup on it, etc. So like this database snapshot step that I told you about, very straightforward. What it does is it says use a context for the Kubernetes cluster that I already have connected to my Codefresh account. Let me zoom in. And then go and apply those create snapshot YAMLs, and then go and create the restore, the persistent volumes that I need, and then it outputs the persistent volume claim into the logs so that we can see it. So very, very simple. We have out-of-the-box steps for working with Helm, so I basically just need to pass in some custom variables, and I basically tell it and this is kind of goes to the value of Helm here. I can say let's use this Redis one. It says custom Redis persistent existing claim equals staging dash voting app Redis. If you remember, that's the name of the PVC that I created. And so I'm just passing a value to the chart with the configuration that I wanted to have, and Kubernetes is going to make it happen. So that was a long-winded answer to your question. Any other questions? Last chance. Going once. Going twice. Okay, feel free to reach out to talk to me afterwards. Also, happy to schedule a one-on-one. If you go to codefresh.io, you can do that. You can also claim the credits. And with that, thank you so much for all your participation and getting through that. That was really, really fun for me. I love doing this. Thank you very much.